Hey everyone, welcome to the Health Inquiry. If you are trying to stay active as you get older, there is a pretty good chance you have a specific bottle sitting in your medicine cabinet right now. It is one of the most popular over-the-counter supplements in the entire world. People take it to smooth out creaky knees, soothe aching hips, and keep joints moving freely. I am talking about glucosamine, a key ingredient in the dietary supplement. Move Free, manufactured by Schiff Vitamins. For decades, glucosamine has been the ultimate go-to natural remedy for joint health. Millions of people swear by it, and for good reason. It helps them keep walking, running, and doing the things they love. But what if I told you that a recent medical discovery has just thrown a massive wrench in how we look at this friendly little supplement? What if something that makes your joints feel great could actually be setting up a hidden roadblock in the brain, specifically for people who are at risk for memory loss or Alzheimer's disease? A major scientific study published in the prestigious journal Nature Metabolism, titled Hyperglycosylation is a Metabolic Driver of Alzheimer's Disease, has uncovered a shocking twist. It suggests that in a brain vulnerable to dementia, glucosamine might actually accelerate memory decline. Today, we are going down the rabbit hole of this incredible new science. We will look at why your brain might be getting sticky with sugar, the alarming evidence scientists just found, and, most importantly, why we don't need to panic just yet. There is a massive debate brewing here, and you deserve to know the whole story. Let's break it down. Part 1. The kitchen of your cells, understanding glycosylation. To understand this brand new discovery, we have to shrink ourselves down and look inside the cells of your body, especially the neurons, which are the specialized cells in your brain that pass messages around like an ultra-fast electrical grid. Inside every single cell, there is a non-stop construction zone. Your cells are constantly building proteins. Think of proteins as the little machines, bricks, and cables that keep your body running. But once a protein is built, it isn't quite ready to do its job yet. It needs to be shipped to the cell's packaging department, places scientists call the endoplasmic reticulum and the Golgi apparatus. In this department, the cell does something beautiful. It decorates the protein with tiny, complex chains of sugar molecules. This decoration process is called glycosylation, pronounced glycosylation. Think of these sugar chains like a high-tech armor casing or a custom barcode. They protect the protein from getting damaged or bent out of shape. They help the protein travel to the exact right spot in the cell. They also act like cellular antennas, allowing cells to talk to each other and pass electrical signals back and forth. In a healthy brain, glycosylation is perfectly balanced. The cell cooks up just the right amount of sugar decorations, glues them to the proteins, and everything runs smoothly. You think clearly, your memories are sharp, and your brain cells stay resilient. But what happens when the packaging department goes into overdrive and starts blasting these proteins with way too much sugar? That brings us to the core discovery of the new Nature Metabolism study, a hidden condition called hyperglycosylation. Part 2. When the brain gets too sticky. For years, when scientists looked at the brains of people who died with Alzheimer's disease, they focused heavily on two famous culprits: sticky protein clumps called beta-amyloid plaques and tangled fibers called tau tangles. These plaques and tangles act like garbage building up in the brain, eventually causing neurons to choke and die. But the researchers behind the 2026 study decided to look at the brain through a different lens, the lens of metabolism, or how our cells process energy and nutrients. Using incredibly advanced, sci-fi-level imaging lasers, the scientists mapped out the chemical landscape of post-mortem human brains. When they compared healthy brains to brains with Alzheimer's, they noticed something unmistakable. The Alzheimer's brains were absolutely smothered in complex sugar chains. They were suffering from severe hyperglycosylation, essentially a massive sugar overload on the surfaces of their brain cells. Even more fascinating, they tracked this sugar buildup across different stages of the disease. In the gray matter of the brain, the area responsible for processing control, thoughts, and memories, the sugar overload got progressively worse and worse as the disease advanced. To figure out why this was happening, the scientists used a clever technique called stable isotope tracing. They essentially put a tracker on glucose molecules to see where they went inside living models. They wanted to know, was the brain failing to clear out old sugars, or was it aggressively manufacturing new sugars? The answer was clear. The brain's factories were stuck in overdrive. It was rapidly pumping out brand new sugar chains and forcing them onto neuronal proteins. So, where does our joint supplement fit into this sticky situation? Part 3. The glucosamine connection. To build these intricate sugar chains, your cells need a raw material, a basic building block. That primary building block is a molecule called UDP-N-acetylglucosamine, UDP-GlcNAc for short. And guess how your body naturally creates that building block? By utilizing glucosamine. When you take a glucosamine pill for your joints, it easily dissolves into your bloodstream, readily crosses the blood-brain barrier, and walks straight into your brain cells. Once inside, it bypasses the normal biochemical stop signs and acts like high-octane fuel for the sugar chain factory. The scientists wondered, if an Alzheimer's brain is already suffering from a dangerous overload of these sugars, what happens if we feed it more fuel? To test this safely, they turned to 2 different groups of mice. One group consisted of normal, healthy, wild-type mice. The second group consisted of special Alzheimer's mice, called 5XFAD and PS19 mice, that were genetically engineered to develop memory loss and brain plaques, mimicking human dementia. They gave both groups a daily dose of glucosamine that was mathematically scaled to match the exact proportion a human takes for arthritis. Then, they ran them through memory tests, specifically, a social memory test where mice have to remember a friend mouse they have met before. The results were completely night and day. The normal, healthy mice took the glucosamine and were totally fine. Their brains did not develop the sticky sugar overload, and their memories stayed perfectly sharp. Their healthy brains possessed natural metabolic buffers to handle the extra supplement without a problem. However, the results for the Alzheimer's mice were deeply concerning. When the vulnerable Alzheimer's mice were given glucosamine, their sugar chain factories went totally haywire. Their brains experienced a massive surge in hyperglycosylation, and their memory scores plummeted. They completely lost the ability to recognize familiar faces, showing severe cognitive worsening. To double-check their work, the scientists did the opposite. They used genetic tools and a special drug, called NGI-1, to shut down the sugar chain factories in the Alzheimer's mice. When they blocked the sugar overload, the mice's memories dramatically improved, rescuing their cognitive function. This proved that hyperglycosylation isn't just a side effect of dementia. It is actively driving the memory decline. Part 4. Real-world evidence. The human shock. Now, it is easy to say, well, that's just a study on mice. Mice aren't humans. And usually, you'd be 100% right to be skeptical. Plenty of things happen in laboratory mice that never happen in real people. But the authors of the 2026 Nature Metabolism paper didn't stop at mice. They decided to peek into the real world by analyzing a massive database of electronic health records from the University of Florida Health System, tracking over 50,000 real patients. They identified patients who had been diagnosed with mild cognitive impairment, MCI, which is the early pre-dementia stage of memory loss, or full Alzheimer's disease and related dementias, ADRD. Then, they checked to see who had a documented history of taking glucosamine supplements for at least a year. What they found mirrored their mouse data. In the early stage, MCI group, patients with early memory warning signs who took glucosamine were 25% more likely to transition and worsen into full-blown Alzheimer's disease compared to those who didn't take it. In the advanced dementia, ADRD group, regular glucosamine use was associated with a 25% increase in the overall risk of mortality, death, during the 5-year follow-up window. Just like the healthy mice, elderly patients in the database who had completely normal brain function showed no increased risk of death from taking glucosamine. The paper estimates that roughly 8% of all dementia patients are actively taking glucosamine. If you scale that up to the millions of people living with dementia across the country, it means over 1 million vulnerable individuals might be taking a daily over-the-counter pill that is actively accelerating their cognitive decline. Part 5. The Big Catch. Why we need a debate. If you have read this far, you might be thinking about running over to your kitchen cabinet and throwing your glucosamine bottle directly into the trash. But hold on a second. Let's take a deep breath, step back, and put on our critical thinking hats. As dramatic as these findings sound, Retrospective medical records have a major built-in flaw that every good scientist must acknowledge. It is a concept called confounding by indication. Let's think about this logically. Who takes glucosamine in the real world? People don't usually take glucosamine for fun. They take it because they have painful osteoarthritis, severe joint degeneration, or chronic knee and hip pain. We already know from decades of medical research that people who suffer from severe chronic joint pain often move around much less. They can become sedentary, lose physical strength, and suffer from higher baseline levels of systemic inflammation. Furthermore, low physical activity and chronic body-wide inflammation are already independently linked to a higher risk of dementia and early death. When the researchers looked at those 50,000 health records, they used statistical matching to balance out patients by age and sex. But they did not completely adjust for how severe the patient's underlying joint pain or physical frailty was. Therefore, a massive question remains entirely unanswered. Did the glucosamine pills cause the accelerated dementia, or were the glucosamine-taking patients simply frailer, in more pain, and dealing with more body inflammation from the start? It is highly elusive to definitively point the finger at the supplement based only on human medical records. Part 6. An additional scientific caveat: the kinetic gap. While the animal data in this study is incredibly thorough, a major piece of the puzzle remains unsolved when translating these mouse findings into humans. What the authors did exceptionally well was their precise, three-pronged validation approach. They successfully matched real-world epidemiological human health records with post-mortem tissue pathology, and then proved a direct causal link by showing that oral glucosamine directly worsens memory function in mice with simulated dementia. However, a key experimental gap leaves plenty of room for caution before we extrapolate this data to our daily lives. The researchers did not measure actual glucosamine concentrations in the blood of either the humans or the mice after consumption. Instead, they relied strictly on standard mathematical formulas to calculate a human equivalent dose for the animals. This creates a major difference in how the supplement enters the body. In the laboratory, the mice received their entire daily dose all at once via an intense direct stomach delivery method called an oral gavage. For an animal, this creates a sudden, massive spike in blood concentrations that completely overpowers the body's natural defenses. In contrast, when humans take a dietary supplement, we ingest it via capsules or tablets that digest slowly in hours. This slower, gradual absorption allows our homeostatic metabolic buffers and the protective blood-brain barrier to process the nutrients safely without getting overwhelmed. Because the blood levels were never tracked, we cannot yet prove that typical human usage creates the same dangerous brain sugar waves observed in the lab. Part 7. Weighing the real-world trade-offs. We also have to talk about the very real, undeniable benefits of glucosamine. For millions of aging adults, this supplement is a vital tool for quality of life. When glucosamine helps a person walk without severe pain, it unlocks massive secondary health benefits. It keeps their heart healthy, burns calories, and prevents obesity. Being able to move pain-free means they can play with their grandkids, which boosts mental health, reduces stress, and fights depression. It allows them to maintain independence, keeping their muscles strong and preventing dangerous falls. If an elderly person stops taking their joint supplement, becomes racked with arthritic pain, stops walking, and spends all day sitting on the couch, their overall health will rapidly deteriorate. That sedentary lifestyle could harm their brain far more than a supplement ever would. This is what makes medicine so beautifully complex. It is almost always a trade-off. What is an incredible medicine for one part of your body might be a hidden stressor for another, depending entirely on your unique health profile. Part 8. A vital message for our viewers. Because this is a brand new study, it is very likely that you are going to see some pretty scary headlines popping up in the news and across social media over the next few weeks. Media reports love to highlight dramatic findings, and it is completely natural to feel frightened or anxious if you or a loved one takes this supplement every day. If you are feeling scared by this newly published research article and the related reports in the media, please remember this critical rule. Do not stop taking your supplement or change your medical routine overnight without talking to a professional. Instead, Use this information as a perfect reason to schedule a conversation with your primary care doctor or neurologist. Show them this study, tell them your concerns, and look at your health as a complete picture. Your doctor can help evaluate your specific memory risk, look at how much your joints rely on glucosamine, and help you make a calm, educated decision. Part 9. What are the alternative paths? If you and your doctor decide you want to step away from glucosamine out of an abundance of caution, you aren't stuck with joint pain. There are plenty of other evidence-based strategies to explore with your care team. First, research continues to show promise in anti-inflammatory natural dietary compounds, such as curcumin from turmeric or sulforaphane from broccoli sprouts, to help manage systemic inflammation. Second, you can talk to your doctor about alternative supplements. Options like omega-3 fish oils, collagen peptides, or even switching to chondroitin alone might provide joint structural support via entirely different biological avenues that don't overload the brain's sugar pathways. Finally, never underestimate targeted physical therapy. Low-impact exercises, swimming, and guided strength training can build up the protective muscles directly around your joints, drastically reducing pain without needing any pills at all. Conclusion: the horizon of brain science. At the end of the day, the new Nature Metabolism study should not be used to demonize a supplement that has helped millions of people stay mobile. Instead, it should be celebrated as a brilliant reminder of just how deeply connected our entire bodies truly are. It proves that brain health isn't just about avoiding plaques or tangles. It is about keeping our microscopic metabolic engines balanced and running clean. The authors of the study have strongly advocated for a large-scale, double-blind, rigorous clinical trial to definitively settle this human debate once and for all. Until then, knowledge is power. By staying calm, talking to your doctor, and balancing physical mobility with cognitive wellness, you can make the absolute best decisions for your personal health journey. Thank you so much for hanging out with me today. If you found this breakdown helpful, make sure to hit that subscribe button, give this video a thumbs up, and share it with a friend or family member who takes joint supplements. Let me know your thoughts in the comments down below. Are you going to talk to your doctor about glucosamine, or are you looking into alternatives? Stay active, keep your brain curious.